What's good, Logan? All right, so just rounding it back, giving you guys some time to work on the problem. If you have any questions about it, here it is. We have to graph 4 sine 3x. So what we want to do is make sure we understand first that we're graphing the sine function. So the sine function has 5 basic points. Remember, sine is always going to start at 0, 0, and then from 0, it's going to go up to 1, and then it's going to go back down to 0, then it's going to go to -1, and then it's going to go back up to 0. Now, all your functions, sine, cosine, we're always going to go like 0, 1, 1, 0, 0, 1, 1, 0. The question is where does it start? Oop, I forgot negatives in there, so let me say that one more time. It's going to go 0 to 1, then 0 to -1, then 0 to 1, then 0 to -1. But where it starts is the difference between sine and cosine. Sine starts at 0 and then goes 1, 0, -1, 0, 1, 0, -1, 0, and so forth. All right, now the x values are going to be our basic angles, our 90-degree angles. So pi over 2, followed by pi, and then 3 pi over 2, or 270 degrees, and then following up with 2 pi. So those are our basic numbers, our basic values, our 5 key points that we're going to be using to graph this thing. Now to graph this, we're going to translate that. We're going to transform them. So we're going to multiply them vertically by 4. That means all of our y values are going to get multiplied by 4 right there. So we're going to multiply all those guys by 4. 0 times 4 is 4. Oops. It's not, it's 0. 0 times 4 is 0. 1 times 4 is 4. 0 times 4 is, we already said it, 0. -1 times 4 is -4. 0 times 4 is 0. So those are going to be our y values. Next, we're going to focus on the horizontal stretch or shrink in this case. Now in this one, b is equal to 3. So since b is equal to 3, what we're going to do is we're going to multiply by its reciprocal. Remember, horizontal transformations always kind of go in the inverted direction. There's a little bit more to that, but as far as we're concerned, it's usually in the inverted direction. So we're going to be using a multiplier of 1/3. So I'm going to write down the 1/3 as a helper to us, and then we're going to grab all of these values, all these x values right here, and we're going to multiply them all by 1/3. 0 times 1/3, well, that is a big fat 0 right there. So we're going to have 0, 0. Next, we're going to do pi over 2 times 1/3. Pi over 2 times 1/3 is pi over 6. So now we have our second point at pi over 6, 4. Then we're going to multiply that by pi. When you multiply pi and 1/3, this gives us pi over 3. So we have pi thirds, or pi over 3. The next one, this one's a tricky one. 3 pi over 2 is going to get multiplied to the 1/3. But in this case, the 3's are going to cancel out, leaving us with pi over 2. So we now have pi over 2, -4. And then our last point, we're going to plug in a 2 pi. So 2 pi times 1/3, and that gives us 2 pi over 3. So we're going to write 2 pi over 3, or 2 pi thirds. I'm going to go ahead and erase this guy over here, the 1/3, and these are our 5 key points to graph the 4 sine 3x function that we are given. So I'm going to partition my graph. My amplitude is 4 right there. So I'm going to go up 1, 2, 3, and 4. Since we got the space, nothing too crazy. I'm going to go down 1, 2, 3, and 4, down to -4. So we're going to go up 4, down to -4. Next, I'm now going to use the points that we just wrote down here to partition our x-axis, Since our amplitude is 2 pi over 3, I'm going to go all the way out to 2 pi over 3. So I'm going to count 1, 2, 3, and 4 equal values. And we'll say that this one is 2 pi over 3. The next one after 2 pi over 3 is pi over 2. So 1 back behind that, pi over 2. 1 back behind that, pi over 3. 1 back behind that, pi over 6. And to double check that we're doing this right, we should land on 0 on the last one, which we do. Now that we've intervaled, or we've taken our x and y axis and put partitions on it, we are now going to start graphing with our 5 key points. 0, 0. Sine likes to start at 0, 0, so we're going to start at 0, 0. Then we're going to move on to pi over 6, 4. So we go to pi over 6, then we go up 4 spaces, and we have our second point right there. Then we're going to graph pi over 3, 0. So we're going to go to pi over 3 and go nowhere. So then we're going to keep our point right there. Then from that point, we're going to go to pi over 2, and then down to -4, all the way down over there. And that gives us this point, followed up with our last point at 2 pi over 3, 0. So we're going to go all the way over there, neither up nor down. We're just going to plop a point right there. All right, last step, go ahead and find your u's or upside down u's and connect them. So we're going to go ahead and connect the u that's right here, right? So we connect that u right there, and that's going to give us our first half of the wave. And then we're going to connect this u right here, which gives us our second half of the wave. As far as grading is concerned, this is all I'm really looking for. But if you wanted to extend this a little bit further, you could draw another u upside down right over there, and that would look as a more drawn out sine function. However, all I'm really looking for is that one. If you have any questions, please ask me tomorrow, and have a great day.